In 2005, a British mechanical engineer, Dr. Adrian Boyer, started a project called RepRap. Similar to the hot glue gun demonstration from the last lesson, the RepRap was a hand-built CNC machine that controlled a plastic filament extruder in 3 dimensions of movement, hence the term 3D printing. The first design of the RepRap was called Darwin. Dr. Boyer released the designs of Darwin to the public. This was a breakthrough for its time, and it sparked the 3D desktop printing revolution. This was also the first machine of its kind with the capability to duplicate itself. The RepRap machines could actually print the parts to easily make another RepRap, minus the electronics. The second version of the RepRap was called the Mendel, and it's still a popular design today. The machine I will be demonstrating in these lessons is called the Solar One Mark I. It was designed by yours truly and built in the Solar One shop. Both the Mark I and the original RepRap machines and many other machines used a plastic filament extruder. This process is also known as fused filament fabrication. Filaments used in these machines come in different materials, sizes, and colors. The first RepRap machines used an acrylonitrile styrene filament, or ABS for short. ABS is a petroleum-based plastic and is used in the same material Lego is made from. It is still a popular filament as of this recording. The next type of filament is called PLA, or polylactic acid. PLA is organic and is made from renewable materials like cornstarch and sugarcane. PLA is the new favorite to use in today's printers due to its ease of use. As of this recording, people are starting to experiment with nylon and polycarbonate. These materials are much more difficult to work with due to their high melting temperatures, so it may be some time before we start to see those materials in use with consumer-grade printers. Each type of filament comes in 2 sizes. Older printers used a 3mm filament, while the more recent printers used a 1.75mm filament. The 3mm filament was good for the older models due to the larger sizes of nozzles. Today's desktop 3D printers have nozzles as small as 200 micron or 0.2 millimeter. Due to their small sizes, the 1.75mm filament is recommended. The printers have a platform, known as the print bed, or build platform. This is where the plastic object will be made. As the print starts, the hot plastic will actually stick to this platform and stay connected for the duration of the print. On some machines like the Mark I, the build platform moves back and forth, creating the y-axis. We'll cover the axis of movement shortly. The build platform usually determines the size of object that can be made. Different printers have various size and build platforms, ranging from a few square centimeters to 1 cubic foot. The Mark I can print 1 cubic foot and is the largest of its class. Let's look at how the filament extruder works. The filament is driven into the extruder by a drive motor. To keep the filament from slipping, a wheel called an idler bearing keeps pressure on the filament to ensure the drive gear always has a good grip on the filament. The filament is then forced down into the heater core. The heater core is a block of metal that contains a heating element and a thermal sensor called a thermocouple. As the heater core raises in temperature, the electronics closely monitor the temperature of the core and the nozzle. Too cold and the plastic will not melt. Too hot and the plastic may become too soft and produce saggy prints, or may start to burn. At this point, the filament is liquid and forced out of a very small hole in the nozzle. It is at this point that the plastic is deposited onto the build platform. Now that we have an understanding of how the extruder works, what happens next? Well, the molten plastic that's forced out of the print nozzle has to go somewhere. If we just deposit the plastic onto the build platform, we would just end up with a puddle of plastic and quite a mess. So to create the actual objects, the print head moves in 3 axes, X, Y, and Z. This allows the print head to move anywhere within the build platform and above it. The X-axis is the left and right movement of the print head, and the Y-axis is the front to back movement. As I described in my last section, some machines move the print head front to back, while other machines like the Mark I move the entire build platform from front to back. Last, there's the Z-axis. This moves the entire print head up and down. This axis also determines how tall of an object you can print at one time. The further the Z-axis can travel, the taller the object can be. If you want to create taller or larger objects, you may have to print the object in multiple pieces.